Welcome to Lesson 2.4. In this lesson, we're going to look at different relationships, specifically population density. So we're going to compare the number of people in the space or the area that they're in. We're going to look at a few examples. The first one is going to be a stage. So here we have a stage, and all the people are evenly spaced, 100 people per 400 square feet. So if we reduce that, that's 1 out of 4, or 0.25. So now if we look at each person standing on his or her own 2 by 2 foot square, we want to compare them. So we have the 25 over 100, which reduces to about 1/4. Right, that's the original stage. Now if we have the 2 by 2 square area, that's also 1/4. So those would be the same amount of space or population density. Now if people moved around the room or around the stage, it would still be the same. So as long as there's the same number of people and the same total area, it's going to be the same population density. Here's a classroom. So 30 students in an 18 by 20 foot area. To find the population density, we would take population divided by area. So 30 divided by 18 times 20. So we are going to do PEMDAS. That means we're going to do that denominator first, figure out what goes on bottom, 18 times 20. So that's 360. And that should be on bottom. Hold on. So we have 30 over 360. Now sometimes we can just reduce and leave it like that. Other times we need to actually calculate it out to the decimal. Our units are going to be people per square foot. And then we round it to whichever place, so 2 decimals, 0.08. Now if we rearrange those people to kind of mimic a county, so in counties we have cities, rural areas, and suburbs. All right. Now in Kern County we don't really have too much of a city, maybe Bakersfield. Rural areas might be like Shafter, Arvin, suburbs, well actually more like Bakersfield, but maybe Delano. So we can compare the city and suburb population densities. Now city means more people are closely living together, so 0.25, whereas a suburb, they're kind of a little bit more spread out, so 0.1. So we can say the city is about 2.5 times more dense, that means more people in an area, than the suburb. Okay, so again, even if people move from the rural area to the city, as long as they stay in the county, the density doesn't change for the whole county. So along with this population density, we want to revisit that unit conversion. So if we have feet, square feet, we might want to be able to change that to square miles. So if I have a 2 by 2 foot square area, so 4, 1 person per 4 square feet, we want to figure out what that means per square mile. So I'm going to multiply that by 5,280 feet over 1 mile, but I have to do that twice because it's square feet and square miles. So that means it has to appear twice. So my calculator, let's do 5280 times itself, and then divide it by 4, which was the area. So 6,969,600. So if we're looking at an average city instead of a dense city, all right, the crowded one we just looked at, they might have 100 by 100 foot square. So that's 10,000. Same steps, multiplying it by that 5280 like we did above, but twice because it's squared. And then dividing it by 10,000 this time. And then writing that answer down. I think we just caught a typo. So we might want to be able to compare countries, in this case China and the US. Now you might be able to guess which one's more dense, right? Which one has more people, which one's smaller. But then we want to actually calculate that to prove our guess. So we're going to take the population of the US, divide it by how many people there are, and then do the same thing for China. Now notice number 9 says to estimate. So then you're kind of guessing, using your math knowledge, your math reasoning skills to figure out which one is more dense, or just your real world reasoning skills too. So they have about the same space, but China has a lot more. So that means China is going to be more dense. And then once you plug those in the calculator, you're going to write them down or enter them in for the number 11.